right of the photograph is the crater Maskelyne, and in the bottom center is the final phases of the descent. The landing area itself is in the smooth area at the top of the picture, just before we arrive at the shadow, or what's called the terminator. We had seen a number of pictures from Apollos 8 and 10, which gave us an excellent understanding of the ground track over which we would pass during the descent. We're now looking out the right-hand window of the crater, and there's Maskelyne W. It occurred approximately 2 to 3 seconds late, and degraded our ability to determine not only our altitude and altitude rate in the final phases, but also, and probably more importantly, our translational velocities over the ground. It's quite important not to stub your toe during the final phases of touchdown. And once settled on the surface, the dust cleared immediately, and we had an exit, and of course the surface was very fine-grained. We could tell that from our view out the window, but there were a surprisingly large number of rocks of all sizes.
This is the view out the right window. Up close to the horizon, you see a boulder field that was probably deposited by some of the impacts in the craters that were behind us. You see, most of the craters have rounded edges. However, there is a variation in the age of these, as we can tell by the sharpness of the edge of the crater. The immediate foreground area we'll see more pictures of later. It was relatively flat terrain, in contrast to looking forward along where the shadow of the lem is cast on the surface, and we see a zero-phase glow around the upper portion of the lem. The general color of the terrain looking down sun was a very light tannish color. This blended as we looked more across sun to a more sharper, well-defined features and more of a gray color. During the initial time period after touchdown, we went through various sequences to prepare us for immediate abort or liftoff if we found that that was necessary. We found we had to vent the fuel and oxidizer manifolds a good bit earlier than we had thought. We went through these various checks and prepared for one liftoff that would occur about 21 minutes after the beginning of powered descent. The ground gave us a stay during this period. We did not have to make use of that. We then proceeded at that point into our simulated countdown, which consisted of checking our guidance systems. We made use of a gravity align feature where the inertial platform of the primary guidance would use the gravity vector to determine the local vertical. We would then compare this with the alignments that we had previously. We also made use of the stars through the telescope and aligning a crosshair by rotating the field of view until the crosshair superimposed on the star. This would give us the angular measurement of the star within the field of view of the telescope. We then determine the distance out by aligning another reticle spiral on this. We went through an averaging technique on board and then fed this information into the computer, and this came up with our various alignment checks. This was all in preparation for a possible liftoff that would occur about 2 hours after touchdown as Mike and Columbia came over for the first revolution. The ground network gave us a stay, and we continued briefly through the remainder of this checklist in our simulated countdown. And at this point, we terminated and powered down many systems on board the spacecraft and went into an E period.